We studied patterns of bone formation and resorption in the faces of African apes. Previous research has shown that new bone is deposited along the posterior and superior margin of the facial bones, causing the face to grow posteriorly and superiorly into the neurocranium. This displaces the face inferiorly and anteriorly. Bone deposition on the lower face of chimpanzees acts alongside this displacement to create a prognathic face, while resorption in the face of humans counteracts this displacement, creating a more orthognathic face. We examined the remodeling patterns in the faces of 3 chimpanzees, 3 humans, and 3 gorillas of the same dental age, first molar eruption, using both light and scanning electron microscopy. Bone formation surfaces can be identified under a light microscope based on the presence of collagen bundles and vascularization. Resorbing areas are more difficult to differentiate from damage, and so possible resorbing surfaces were subsequently examined with a scanning electron microscope. Some of these examined surfaces proved to be forming bone, but others displayed the distinctive Hauschipp's lacunae characteristic of resorbing bone. These are small holes about 20 to 50 microns across in which osteoclasts once resided. These 9 half faces are our results. Blue surfaces were positively identified as forming bone surfaces under the light microscope. Circles are areas examined by the scanning electron microscope. Blue circles indicate areas that were primarily forming bone, and red circles indicate regions that are primarily resorbing. Circles with both red and blue were points where both types of bone surfaces were clearly defined. Areas that were inferred to be forming or resorbing based on the SEM results are hatched blue or hatched red, respectively. Areas where the margins of the forming and resorbing bone were unclear were left white. This lack of clarity was generally taphonomic rather than biological. Overall, our findings agreed with previous studies that found that the lower face of humans are more resorptive than those of chimpanzees. Gorillas, however, were intermediate between the two, complicating the polarity somewhat. All 3 gorillas had some resorption along the lateral part of the alveolar margin, which wasn't seen in the other taxa, while 2 of the humans had resorbing surfaces above the orbit, which also wasn't seen in non-humans. Aside from those, however, the areas most likely to be resorptive were similar across all 3 species: the infraorbital region, along the zygomatico-maxillary suture, and the subnasal region. Further, a high degree of intraspecific variation in the exact pattern of bone remodeling was observed, even in this small, age-controlled sample. Overall, our findings suggest that a high degree of variation characterizes remodeling patterns in the face of all African apes. Within that pattern of variation, many of the same regions are likely to be resorptive in any given individual of any given species. But any given area is more likely to be resorptive in a particular human than in a particular non-human African ape, and those areas are more likely to be larger. Thanks so much to those who provided specimens, to those who helped me learn the equipment, and to you for listening. Have a great time at the rest of the meetings.